Yeah, good evening, guys. Everyone can hear me. Online students, is my voice is loud and clear? Right. So let's start the session. In the last class, we are discussing regarding the types of variables. Within the types of variables, we are having continuous, discrete, whether discrete count or discrete categorical, and along with the time series variable. So these are the different types of variables which are available within the structured data. Within the structured data, you can have either continuous or discrete or time series variable. And for discrete variable, if you are having any kind of discrete variable, for example, let us take one of the example is gender, where I'm having male, 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 female, female, something I'm having like this. For this discrete variable, we are going to make a plot called as bar plot, where this discrete variable categories we are going to take on the x-axis, whatever the categories we are having on x-axis, and whatever the count of total number of values are available, that we are going to take on the y-axis. So here the value is 4 and number of females are 2. So just we are going to draw this type of thing. This is called as bar plot, where we are having the bars. These are called as bars. Now this is called as a bar plot. So if you think, if you see from the plotting perspective, it is called as bar plot. If you see in the statistics, this is called as frequency and this is called as distribution. So this is called as frequency distribution. In statistics, it is called as frequency distribution. Generally, we used to call it as bar plot, simple bar plot, right? So we have discussed yesterday about if any discrete variable is there, how we are going to take the frequency distribution. So just we are going to mention whatever the categories are there, each category on the x-axis. On x-axis, each category on x-axis. Each category on x-axis, you're going to take each category on the x-axis and their frequency. Frequency means simply nothing but count. How many of them are there that you are going to take on the y-axis. This is called as discrete frequency distribution. Okay, this is called as discrete frequency distribution. Whether it is a discrete count variable or whether it is a discrete categorical variable, the concept remains same, right? So this is for the discrete frequency distribution. Is that clear? Discrete frequency distribution. Since we are applying on a discrete variable, so first word is says discrete, and we are going to apply the concept called as frequency distribution. So it is called as discrete frequency distribution. Done. Discrete frequency distribution. Frequency means nothing but count. How many are available? Just take whatever the number, whatever the things you want. Apart from gender, you select anything. For example, I'm collecting the liver patient data set is there. In that, two categorical variables are there. One of the categorical variable is gender and another categorical variable is liver patient, either yes or no. So whatever the categories you are having, yes or no, you are going to write on the x-axis. How many yeses are there? You are going to take that much of height. How many no's are there? That much of height you are going to take. So this is called as frequency distribution. So this we are going to apply on the discrete variable. So it is called as discrete frequency distribution, right? Now, yesterday we have discussed what is discrete frequency distribution. Now in today's class, we are going to see the continuous frequency distribution, at the same time continuous probability distribution. Let's move on to the continuous variable. This is all the things which we have done for the discrete variable. Now let us take a continuous variable. Now continuous variable means, let us take a continuous variable in this way. Example of your choice, anything you can select. I'm taking the weight. Okay, weight of the students. I'm having with respect to the weight of the students like 68 kgs, 62.4 kgs, 69 kgs, 72, 75, 80, 81, 59, 54, 56, something I'm having. 3, 6, 10. Total 10 values are there. Okay. I'm having some student weights are like this. Everything in the kgs. Now, generally the kg weight means it is a continuous variable. In my data set, whether it is not having any kind of float value also, still it is a continuous variable. Weight is always a continuous variable. Weight, height, measure, centimeters, everything will be continuous variable. In your data set, float values are not there means, or decimal values are not there means, you should not consider as a discrete count. What happens if I consider a continuous variable? Sir, assume that this is basically it is a continuous variable. Assume that I have wrongly assumed this one by seeing the data. I assumed it is as a discrete count. I assumed as a discrete count. What happens? For 68, you are going to draw how many students are there for exactly 68. How many students are there for exactly 69? How many students are there for exactly 70? How many students are there for weight of 71? Like that, for each kg, you are going to draw one bar. For example, the students' weights are starting from 50 to ending with 80. The range is from 50 to 80. Okay, the minimum value is starting from 50. The maximum value is ending for 80. For each of the 1 kg, you are going to draw one bar. So for 30 kgs, means 30 values, you are going to take 30 bars. Now, what type of analysis you are going to do if the student weight is in terms of 68, exactly 68 weight of students are 2 are there. 69 kgs, 2 are there. 70 exactly kgs, 3 are there. What type of analysis you are going to apply? So if you consider a discrete count variable, for each of them, for each value, you have to make one bar. Now, sir, instead of discrete count, if I take the same data as a continuous data, the same data, if I feel this one as continuous, now what happens? Means from where it is starting? 50. Take the starting value 50. 50 to 60. 60 to 70. 70 to 80. 80 to 90. Now, from 50 to 60, how many records are there here? 1, 2, 3. 3 records are there. Draw a bar up to a height of 3. Okay, height is 3. This height is 3. Earlier, whatever we have drawn, that is for individual category we have drawn. For the discrete variable, each category we have drawn. Now, what we are going to take? Interval. In the continuous variable, we are going to consider a interval. This is called as 50 to 60 is called as interval. In the given interval, how many values are there? From 60 to 70, how many data points are there? 1, 2, 3. Again 3. So this one also 3. Now 70 to 80. 1, 2. Only 2 records are there. This is 3. This is 3. And 70 to 80, 2 records. From 80 to 90, again 2 records are there. Now you might be asking a question. Sir, here exactly 80 is there, na? This 80, whatever the 80 number is there, this 80 number comes under 70 to 80 interval or 80 to 90 interval? To which interval it will come? 80 is both the sides, right? 70 to 80 and 80 to 90. In the both the cases, 80 number is available. Now, which category it will come is, by default, the second value of each interval is not included. The second value is not included. Now, if the second value is not included, you might ask me a question. Sir, if second value is not included, then you can take only 70 to 79, 80 to 89, you can take like this now. Why you are taking exact 80? You can take up to 79 only. But if I'm in my data set, 79.9 is there. Now, where I have to write this one? That is the point. For example, if I take 79.99 in my data set, 79.99998 is there. Where I have to write this one? So that is the reason they will write with respect to the second number also will be included here, but the exact value will not be included. The last value will not be included. Is that clear, guys? Got the point? So now continuous variable means we are going to take a interval. Based on the interval, we are going to draw. So this is on the x-axis. Once again, you are going to take the intervals of the continuous variable on the x-axis. On the y-axis, you are going to take the frequency only. Y-axis is frequency only. This is called as frequency. And this is called as, again, distribution of the data. How the entire data was distribution. So it is called as continuous frequency distribution. So the continuous frequency distribution, all the bars will be attached to each other. For continuous variable, the bars will be attached to each other. Is that clear? Got the point? So this is called as frequency distribution. Frequency distribution means in terms of you are having the continuous variable, first you have to take the frequency values. Right? Now, sir, can you explain with one more example? Okay, don't worry. You have not written the example also, don't worry. I'm writing one more example. Okay, take as per your choice, any values. 1, 4, 9, 14, 16, 18, 20, 21, 28, 32, 39, 34, 36, 40, 41, 42, 43, 44, 45, 46, 90, 91, 86, 76, something. 3, 6, 9, 12, 15, 18, 22. Let us take 64, 69, 51. 25 values I have taken. Or let us take with a round figure of 20 only. So why I'm taking round figure means for calculation purpose. Later we have to calculate the probability, right? Divide also we have to do. That you should not forget. So for calculation purpose, if I take that as 4 by 22, the calculation will be different. If 4 by 20 means calculation will be easy. For my calculation purpose of denominator, if the round figure is there, calculation purpose easy, I'm making us 20 values or 25 values like that. That is the reason I'm selecting the values. Right? Now, let us take a data set like this, where you are having a data. Now, in this data set, now what I'm going to do, first, I'm going to take from 1 to 10, how many values are there? This is the interval. Interval is 1 to 10. How many data points are there? How many data points are there between 1 to 10? 3 data points are there. 3 values. This is frequency. Okay, frequency are 3. Frequency means nothing but count. From 10 to 20, how many are there? 3 of them are there. 20 should not be included because right side part should not be included. How many are there? Only 3 are there. Okay. Now 20 to 30. 1, 2, 3. Again 3 are there. Next 30 to 40. Hey, what is this? Okay. Next 40 to 50. 1, 2, 3, 4, 5, 6, 7. And next one is 80 to 90. 60 to 70, 50 to 60, how many are there? 0. 60 to 70, 0. 70 to 80. 70 to 80, 0. 80 to 90. 80 to 90 means 0. 90 to 100 means 1. This is the table. This is the table where I have drawn the frequency table. This is called as frequency table because you have represented the data in the table now. So it is called as table. This is called as frequency table. Now the same frequency table, whatever you are having the frequency table, now the same thing you are going to represent by using a plot. Now first you have to start with 1, 0, 0 to 10. With everything increment is 10, 10, 10. Every time you are adding 10, 10, 10. So starting with 0, 0 to 10. How many records are there? Means 3 records. Go a height of 3. Next 10 to 20. So 10 to 20 means this one will be attached to this. 10 to 20 means this one, 3. Next 20 to 30, 3. 30 to 40, 3. 40 to 50, 7. 50 to 60, 0. 60 to 70, 0. 70 to 80, 0. 80 to 90, 0. 90 to 100, 1. A height of 1 bar. This is the plot. This is called as frequency distribution. So this is a frequency. This is the frequency. This is the distribution. So this is called as frequency distribution. Is that clear? For this data set, this is the frequency distribution. So this is called as frequency distribution of a continuous variable. For the continuous variable, we have to take an interval and the bar should be attached to each other. And whereas discrete variable, each of them are independent to each other. There is no interval for that. There we are going to take individually. And next, second one is there in the discrete variable, all the bars are not attached to each other. But here each bar is attached to each other. Is that clear? That is the difference between the continuous frequency distribution versus discrete frequency distribution. Clear, guys? Now, for this data set, this is called as frequency distribution. Now, for the same data set, now tell me what is the probability distribution? How many values? What is the probability of a value? I want the probability of a value which is between 0 to 10. 0 should be included, 10 should not be included. How many values are satisfying this one? 3 values are satisfying, which is 3 by 20. That is the probability. How many values are satisfying between 10 to 20? 20 should not be included. How many values are satisfying? 3. 3 by 20. Now, if you are considering this same example, this is the frequency distribution. If you take instead of this value 3 and this value is 7, instead of considering 3 and 7, if you consider here the probability of each interval, then it is called as probability distribution. If you consider probability means probability distribution. If you consider frequency means frequency distribution. That is the difference. Is that clear? Now for the same data set, from 0 to 30, 3 by 20, 3 by 20, 3 by 20, 3 by 20, 7 by 20, and this is 1 by 20. Now what is this one is called as? Earlier it is frequency, now it is called as probability. This is now probability. Now this is called as probability distribution. Earlier it is called as frequency distribution. Now it is called as probability distribution because you have represented on the y-axis probability. On the y-axis, what you are representing, that is the distribution. On y-axis, if you are representing probability means probability distribution. If you are representing in terms of frequency means frequency distribution. Take any data set of your choice. Any data set, any values of your choice. Right? And just you apply this interval. But whatever the interval is there, every interval should be of equal size, not unequal. Means, for example, first interval you are considering 0 to 10 means second one should be 10 to 20 only. You can't take from 10 to 25. You can't stay in the interval. Interval should be fixed. Now, generally, how this interval is calculated? Now, sir, you have selected 0 to 10. Why? You can take 0 to 50 and 50 to 100. Nah? 2 bars only you will get, right? Why you selected 0 to 10 only? Why the reason? How to calculate the interval? How to calculate the interval? Interval is calculated based on the number maximum value minus minimum value divided by number of bars. Whatever the number of bars you want. So here I have taken the maximum value as 100, minimum value of 0 divided by 10. So I got the interval of 10. Right? So in your data set, what is the maximum value? That should be your maximum value. You can't select your maximum value. In the data set, whatever the maximum value is there. For example, in exactly to be more precise, for this data set, what is the maximum value? 90. What is the minimum value? 1. Divided by 10 bars I want. Means 89 divided by 10. 8.9 means basically it will start from 1 to plus 8.9. What is 8.9 means 9.9 up to 9.9. Basically, this is the interval we have to consider. From 9.9 to plus 8.9. You have to add like this. Basically, that is the one. For example, now let us change this one. Instead of this, take this one as 100. Instead of this, take it as 0. Now 100 minus 0 divided by 10. Now starting from the 0 to 10, 10 to 20, 20 to 30. For this data set, this is the same table. If you want, you can check, recheck once again. For this data set, starting 0 to ending 100, for this data set, this is the table and this is the intervals. Exact interval, perfect interval, if you want to calculate, means maximum minus minimum divided by total number of bars. By default, the total number of bars is equal to 10. Sir, I want to change the number of bars only to 2. Then what happens? 100 by 250. So 0 to 50 as 1 bar, 50 to 100, 1 more bar. Right? By default, the number of bars is equal to 10. If you want to change only, you have to change. That is as per your requirement. No, sir, I don't require, miss anything special in that. Nothing special is there. By default, generally everyone will consider 10 bars on. By default, 10 bars, and you have to consider 10 bars by default. Right? Is that clear, guys? So continuous frequency distribution, at the same time, continuous probability distribution. Sir, can you explain how the probability is 20? It is 10, right? So here, yeah, you got it right. Okay, done. So divide by 20. Total number of values are 20. In the above example, total number of values are 20. So divide by 20. How many of them satisfies your condition? Divide by total number of possibilities is called as probability. Continuous frequency distribution and continuous probability distribution, both are clear. Now, let us get into the next one. Next concept is called as percentile. Now, next concept is called as percentile. So before moving to the percentile, to the next concept, instead of keeping the heading, of course, we are going to discuss the same only. Now, as students are asking the PPT or notes in terms of, so I'm going to use the same. So this is the PPT which I'm going to upload, right? So statistics is nothing but measure and analyze on the day one, which we have discussed. And population is entire things. If you consider everything is considered as population, whereas sample means part of the population. Subset of population is called as sample, right? Population says with respect to everything, right? Whatever the things, for example, if you want to consider the feedback of students, means all the students feedback is considered as population. If at least one of them is missing also, it is considered as sample only, right? Now, why we are going to work on the sample every time is it is less time consuming, less costly, and finally, sampling is the only option. That is the main reason of selecting the sample. We are going to work on the sample, and based on the sample, we are going to estimate the population. So that is called as inferential statistics. In the statistics, we are having inferential and descriptive. Now, what is meant by descriptive? Descriptive means collecting and describing the data. Descriptive statistics means just describing the data. Where inferential statistics means you are estimating the population based on the sample, right? And whatever the data we are having. Now coming to the data variables, different types of variables are available. What are the different types of variables means we are having with respect to continuous variable and discrete variable. So continuous variable are called as quantitative data. Quantity, they will tell about the quantity. And whereas discrete variable. So here the discrete variable continuous means which are having with respect to decimal values possible. It is called as continuous variable. If there is no decimal value possible, then it is called as discrete count. Whether it is a continuous variable or whether it is a discrete count, both of them in the numerical format. Whether discrete count also will be in the numerical format, continuous variable also will be in the numerical format. So all the numerical format data is called as quantitative data. Every numerical format data is considered as quantitative. Whichever is in the text data, that is called as qualitative. Quality. It will tell us about the quality. It will tell us about the quantity. Quantitative. Quantitative. Quantitative means, remember only one thing called as quantity. Quantity means some numeric. 1 kg, 2 kg, 1.5 kg. Quantity. How much quantity? Qualitative. Qualitative. means quality. Quality means good or bad, something. How the quality is there, good or bad, right? So quantitative data will always says about the text, and quantitative data always gives with respect to the numeric. Numerical data is considered as the quantitative data. Text data is considered as the qualitative data, right? Now in the numerical, we are having continuous and we are having discrete count. Count means there is no possibility of float. For example, number of pets you are having. 0, 1, 2, 3, or 30, 40, whatever the number you'll tell, you can't say that 2.7 pets I'm having, where the decimal value is not possible in the discrete count. For continuous variable, decimal value also possible, right? Now, coming to the categorical, within that nominal is available and ordinal is available. Nominal means there is no order, there is no logical order, or there is no natural sequence. Example is hair color. Whereas ordinal data, there is having some natural sequence. Example is your letter grades. Your letter grades, A grade is better than the B grade, B grade is better than the C grade. If you ask ABC as a number, as a letters, what is A letter, what is B letter, what is C letter, means there is no difference. But if you say letter grade, A grade, the word grade, if you add, if the column name says that, just the letters A, B, C, D, then it is a nominal data. If the column name says that it is grade A, B, C, D, then they are ordinal data. In this case, it is ordinal. In this case, it is nominal. Same ABCD. ABCD is common. But in one case, it is grades. In one case, they are just letters, names. They are just names. Right? Both are different. So when you are considering as a names, you have to consider that one as a nominal data. When you are considering them as a grade, you have to consider as a ordinal data, because A grade is better than the B grade. B grade is better than the C grade. C grade is better than the D grade. Right? All these things are better than the F grade. When compared to fail, F means everyone knows that is fail, common, standard one. Right? So these same letters, whatever the letters are there, letter grades are considered as the ordinal data. Now, example of hair color is nominal data, because they are just names, color names, they are just names. Wherever the names are there, all the names are nominal only. Whether it is a student name, whether it is a professor name, whether it is a country name, whether it is a state name, whether it is a pet name, whether it is a color name. Everything name only. Name is nominal. They are just names. In the name, that name is better than this name. No one is having the rule like that. Nothing rule is there. Okay. Every name is same. Now, for categorical data, if you are having a categorical data, we are going to represent them in the bar plot. If you are having a continuous data, that we are going to represent by using a frequency distribution. This is the frequency distribution. This frequency distribution is also called as continuous frequency distribution, is also called as histogram. The continuous frequency distribution is also called as histogram, another name of continuous frequency distribution. Now just observe here. And the data from 90 to 100, how many data points are there here? In the given data, total, how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 data points. Out of which 90 to 100, how many values are there? 100 should not be included. 1, 2, 3, 4, 5 values. So you are going to draw a bar up to a height of 5, where the height is 5. Next, 100 to 110. 1, 2, 3, 4, 5, 6. Up to a height of 6. Next, 110 to 120. 1, 2, 3, 4. Up to a height of 4. Next, 120 to 130. 130 should not be included. 120 to 130 means 1, 2, 3, a height of 3. And 130 to 140, 1. Where is second one? Here, 138, 2. So total 2. So you're just representing whatever the number of count is there that you are representing here. This is a continuous variable because that is weight of the student in LBs. The weight of the students in LBs, the weight is the variable name. For that variable name, you have to take as a continuous variable. For continuous variable, you have to represent them in the interval, right? Now, this is called as continuous frequency distribution. So here, by convention, we can say each interval doesn't include the right endpoint. In every interval, the right point will not be included by convention. Convention means by default. By default. Immediately, the student will ask the question, sir, we can take from 110 to 119 or 120 to 129 only. Why we are considering the next number means, as I have already told you, if I am having 119.7, that I can't keep if I select like this. So that is the reason we'll take the second one, but at the same time, will not include the right side point. By default, the right side point is not included. Is that clear? Now, for time series data, for discrete variable, I have shown you discrete frequency distribution. For continuous variable, I have shown you continuous frequency distribution. For time series data, how we are going to represent the time series data means just only one plot called as line plot or time series plot. As the time changes, how the value will change. For example, I'm having the data like this. Let us take one example like this. Month and sales. January month, the sales is 20 crores. Okay, 20,000 or 20,000 or whatever it is. Let us take in crores or thousands or whatever the number, 20. In the February, I'm having 10. On March, in the March month, I'm having 40. In the April month, I'm having only 5. In the May month, I'm having 30. In the June, I'm having 25. July, 40. August, 50. Something you are having. Now, this time, whatever the time variable is there, this time variable should be on the x-axis. Whatever the time variable should be on the x-axis. That is Jan, Feb, March, April. If it is dates, means dates. For example, instead of January, 01/04/2023, 02/04/2023. That is March 1st, March 2nd, March 3rd, March 4th, March 5th, March 6th. Sorry, I mean April 1st, April 2nd, April 3rd, April 4th, April 5th, 6th, 7th, 8 is there. Dates are there. You have to write the dates on the x-axis. Month is there, month on the x-axis. Week is there, week on the x-axis. Year is there, year on the x-axis. Whatever the time series variable is there, that time series variable should be on the x-axis. April, May, June, July, and August. Okay, the entire time series variable on the x-axis. Now you consider the y-axis. Y-axis is nothing but first one is 20 on January 20. 20 means this is the point. Now February 10. 10 means this is the point. Next 40. 40 means this is the point of 40. Next April 5. Next May 30. In the May 30. Next June 25. June 25. Next July 40. August 50. Now just attach each of them in the sequential order. Every data point you have to attach in the sequential order. This is called as time series plot. Time series data you have to take, and the data you have to attach all the data points in the sequential order, because this is a sequential data. First this was happened, after this one has happened. Sequential order is important in this. Sequential order is important in this case, right? So if you attach all the data points in the sequential order, then this is called as time series plot. This is called as time series plot. Is that clear? So the time variable you are going to take on the x-axis, and the value on the y-axis, whatever the value. In the stock market, we are having the everyday the data every day, that is April 1st, what are the share price, some share price. On next day, the share price, next day, the share price, next day, the share price, like this. We are having each of them, the share price. This graph is with respect to the dates on the x-axis, value on the y-axis. This is a time series plot. For time series data, we are going to use the time series plot. For discrete data, discrete frequency distribution. Okay, for discrete data, discrete frequency distribution. Is that clear? Can I erase this one? Right? Now, for discrete data, discrete frequency distribution, which is also called as bar plot. Discrete frequency distribution, which is also called as bar plot, where you are having on the x-axis the discrete variable categories on the x-axis and their frequency on the y-axis. And this is called as bar plot. It is called as bar plot. Now, if you are going with the continuous variable, for continuous data, we are going to have continuous frequency distribution. Continuous frequency distribution. On x-axis, we are going to take the interval of values and their frequency. Interval of values and their frequency. And the bars are attached to each other. Whatever the bars are there, everything are attached to each other. And this is called as histogram. For continuous data, continuous frequency distribution, which is also called as histogram. Now, for time series data, next one is for time series data. For time series data, we are going to use a plot with respect to time series plot, which is also called as line plot. Time series plot. We are going to take the time series plot, which is also called as line plot, where we are having the time variable on the x-axis and the value on the y-axis. For three different types of data, three different types of representation. Each variable will be represented in a different way, analyzed in a different way. We are going to understand in a different way. Right? Discrete variable should be understood in a discrete variable analysis. Continuous variable should be understood in a continuous variable analysis. Time series variable should be understood in a time series analysis. Right? So continuous frequency distribution is also called as histogram. This diagram, whatever the diagram is there, this diagram name is called as histogram. Whatever this diagram name is there, the diagram name is called as line plot. These are the diagram names. These are generally in the statistics, they are called as frequency distributions. Right? Clear, guys? Done? Everyone has taken the notes. Can I erase? Right? The same thing in the PPT also you can identify. In the PPT also it will be there. And I'm going to share you the PPT also. Right? I will upload the PPT after the class. And next one, we have discussed with respect to the measures of central tendency. The first one is called as median. Median means centermost value, whichever is in the center position. If you are having odd number means directly the center position easily you can identify. Only one number will be there. If it is even number of data points are there means average of center two values you have to take. That is 154 plus 155 divided by 2. In this example, it is the like this. So median represents the middle of a ordered data, middle value of a ordered data. So this is focusing on the position. Middle position value of a ordered data is called as median, right? Next, what is called as mean? Mean means nothing but sum of the data points divided by total number of data points. For the given data set, if it is a population data, mu sigma x divided by caps lock n. Caps lock n represents the population data. Small n represents the sample data. So mu is population mean sigma x by caps lock n. So just you are going to add all the data points divided by caps lock population data. Sample mean is represented by x bar. X bar is equal to sigma x by small n. You have to write small n. Whenever the sample you are working, you have to work on the small n. So the small n you are going to take and you are going to take the average, right? Next one is mode. Mode is most repeated value. Mode means most repeated value, which is getting most repeated. In this case, 154 number is repeated 3 times. So mode is equal to 154. Right? Next, measures of dispersion. Now, what is meant by measures of dispersion? Range. Range means nothing but your maximum value minus minimum value. So for a given data set, what is the maximum value is 196. What is the minimum value is 139 for this data set. Yesterday, I have explained for a different data set. Each in a flow, whatever the data set we get, that one we can select. It is not fixed that every time we have to take this one only, right? So for this data set, this is the maximum value. This is the minimum value. Maximum minus minimum gives you the, with respect to called as range. And deviation. Deviation means how much it is deviated from the mean. X minus X bar or X minus mu. How much it is deviated from the mean. So absolute mean absolute deviation means sigma of X minus mu divided by caps lock n. If it is a population data. For sample data, X minus X bar divided by small n. Similarly, variance, that is X bar minus mu whole square divided by caps lock n, and which is represented by sigma square, right? And standard deviation is nothing but square root of variance, which is represented by sigma. That is called as standard deviation. For this data set, I have calculated X minus mu whole square. And from that, we calculated the variance. From that, we have calculated the standard deviation, assuming the entire data is a population data. Now, if the data is a sample data, then we have to do with respect to X minus X bar whole square divided by n minus 1. Here, it is sample data. So 4 data points are there. 4 minus 1 is just 3. So based on the data, whatever the data we are having. So in the given question itself, they'll write clearly whether it is a population data or a sample data, right? So sample standard deviation is given by the formula of X minus X bar whole square divided by n minus 1. If it is a standard deviation, is square root of. Is that clear? These are the things which we have discussed till now, right? Now, so samples variance and sample standard deviation formulas are given as like this, where you have to consider n minus 1 in the denominator. Now, next one is, what does standard deviation tells us? If the standard deviation is less, means all the data points are very close to the mean. If the standard deviation is very high, means all the data points are far away from the mean. So standard deviation tells us how much the values are close to the mean. Okay, standard deviation tells us how much the values are close to the mean, right? If they are very close to the mean or very far away from the mean. If the standard deviation is low, means the data set will be like this. Means everything will be close to the mean only. Every data point will be almost close to the average only. Whatever the number of students are there, every student weight will be almost close to the average, center value. In this case, whatever the average value, let us take the average value is this one. From here to here, the distance, whatever the distance is there, this is the short distance. So distance is small. Now in this case, case number 2. In this case, what happened? If this is the average from here to here, the distance is large. The deviation is large. As deviation is large, means standard deviation value will be high. Is that clear? So what does the standard deviation tells means how much the close the values in a data set are to the mean value. Right? This also we have discussed. Next one is concept is called as coefficient of variation. The next concept is called as coefficient of variation. Now, what is meant by coefficient of variation means nothing but standard deviation divided by mean into 100. For a given data set, you are going to calculate some standard deviation, right? Standard deviation divided by mean into 100 tells us the coefficient of variation. For a given data set, what are the data set? First, we are going to calculate some mean value. From that, we are going to calculate the standard deviation. Quotient of variation is nothing but sigma by mu into 100, which is nothing but sigma is 4.6 divided by mu is 29 into 100. For the given data set, whatever the mu is there and whatever the standard deviation is there, right? That is called as quotient of variation. Quotient of variation is the ratio of the standard deviation to the mean, right? Next one is measures of shape. Next heading, keep the next heading called as measures of shape. Next heading is called as measures of shape. Now, what is the measures of shape test means? Symmetry, whether the data is symmetrical or non-symmetrical. Shape of the data. Whether it is a symmetrical data or non-symmetrical data. Okay. So, for example, let us take here. This is the one example. This is the second example. In example 1, let us take like this. Okay, if I draw a center line, for this, if I draw a center line, whatever the center line is there, if I draw a center line, now left side and right side, it is symmetrical. Same, whatever you are observing left side and the right side also same will be there. So then it is called as symmetrical distribution. Now let us take one more example. Right now for this, okay, I'm having like this. Now for this data set, the center value is this one. Now left side and right side is symmetrical. No, this is called as non-symmetrical distribution. This is called as symmetrical distribution. If everything is symmetrical from the center, center means mean. Center means mean. From the mean and left side, whatever the diagram, and right side the diagram, if everything is same, then it is called as symmetrical distribution. If it is not symmetrical, then it is called as unsymmetrical distribution. Okay. Symmetrical distribution means from the left side and right side will be the same. Then it is called as symmetrical. Symmetrical distribution means left and right diagram will be the same. Left side and right side will be same. Then it is called as symmetrical distribution. This is called as non-symmetrical distribution. Non-symmetrical or unsymmetrical, whatever the name you want, you can keep. Non-symmetrical or unsymmetrical distribution. Symmetrical distribution is also called as normal distribution. This is also called as normal distribution. Symmetrical distribution is also called as normal distribution. Non-symmetrical distribution is also called as skewed distribution. Okay, this is called as normal distribution. This is called as skewed distribution. Okay, what is meant by skewed distribution? Skewed distribution means the distribution is non-symmetrical. Simple. Whichever the distribution of the data is non-symmetrical, it is called as skewed distribution. Non-symmetrical. What is meant by non-symmetrical? Non-symmetrical means from the center, see left side and right side. If both are same, means symmetrical. If both are different, means non-symmetrical. From the center point, you have to see left and right. First, you have to identify the center point. Center point is nothing but your mean point. From the mean point, left side and right side, everything is same, then it is called as symmetrical. Otherwise, it is called as non-symmetrical. right? Is that clear? So symmetrical distribution is also called as normal distribution. Non-symmetrical distribution is also called as skewed distribution. Right? Now, coming to the symmetrical distribution, first one. Symmetrical distribution means both sides are same. So non-symmetrical means both sides are different. Right? So this is the example for the symmetrical distribution, where if you draw a center line, this is the center line. If you take a center line, left side diagram and right side diagram will be the same. This example represents the symmetrical distribution, right? Now let us go with the unsymmetrical distribution. For symmetrical distribution, the mean and median will be the same. For any symmetrical distribution, the mean and median will be the same. Now you'll get a doubt. How, sir? Let us take one example. From 0 to 10, you take two values. From 10 to 20, you consider two values. Four values. Okay. From 20 to 30, you consider six values. From 30 to 40, you consider again six values. From 40 to 50, you consider four values, and for 50 to 60, you consider two values. This is a symmetrical distribution. Now, this is the data for symmetrical distribution. Now you select whatever the data you want. You take as per your choice. From 0 to 10, select any two numbers, 5 and 6. From 10 to 20, select any four numbers, 11, 12, 18, 19. Anything as per your choice. If you can tell fastly, tell me. As per your choice. There is no rule like that. Anything as per your choice. From 20 to 30, 23, 25, order data. Let us make order data because median will be calculated, right? We have to calculate the median also. 27, right? And still two values. Between 20 to 30 only. 21, 28, right? From 30 to 40, six values. Six values. 41, 42, 43, 44, four values, 51, 52, two values, right? For this data set, this is the diagram. Actually, from data, we have to draw the diagram. Now, from the diagram, I have drawn the data, right? Anything is same. Okay. Now, for this data set, calculate the average value. For this data set, calculate the average value. For the same data set, calculate the median value. Both will be the same. If you want, you can try after the class. After the class, try. Exactly, not exact value. Almost close, not perfect exact value. If you want, you can check. So for this, what is the median value? Total, how many values are there? 2, 4, 6, 12, 18, 22, 24. 24 values are there, miss even number. 24 plus 1 divided by 2, that is nothing but 12.5. Miss 12th one and 13th record. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Miss 29 and 31. These two average, which is 30. The median is 30. For this data set, the median is 30. Median is 30. So, which is center value. Right? Calculate the mean also. You will get same 30.5 or 31 or 31.2, something very close to the 30 only you will get. If you want, you can try. If you want, I will wait also. If you can try, miss, I will wait also if possible. Answer will be the same. 100% it will be the same. Because what are the rules they have made, it is for all the data sets they have created, not for a particular data set. For any normal distribution data is there, miss, it has to follow the rule that mean should be equal to median. Right? Is that clear? Now, here, if you are having for symmetrical distribution, the mean is equal to the median. The mean will be equal to the median. Right? Now, Skewness. What is meant by skewness? Skewness means in terms of which is not symmetrical, either left side or right side. If you take the average value will be here, somewhere here. Left side, the diagram will be different, and right side, the diagram will be different. If you take the average value, this is the average value, left side and right side, the values will be different. So then it is called as asymmetrical, which is asymmetry. Asymmetry or non-symmetrical or unsymmetrical or skewed distribution. Everything are same. Okay. Asymmetry or unsymmetrical, non-symmetrical, and skewed. Everything are same. 4 different names. Okay. Everything are non-symmetrical only. Finally, everything says that left side and right side same. Both are not same. Right? So left side, whatever we are having the data, that is with respect to, and right side, both are not same. Now here we are having 2 type of distributions within the skewed distributions. Within the skewed distributions, we are having 2 types. One is called as left skewed. Second one is called as right skewed. One is called as left skewed. One is called as right skewed. What is meant by skewed? Skewed means nothing but less number of values on the left side. Means the height of the bars will be left side very less, and whereas the right side, the height of the bars will be very high. So example of that one, left skewed and right skewed. We are having 2 types. One is called as left skewed distribution. The second one is called as right skewed distribution. Now let us take an example. Left skewed distribution example is this one. So if you observe, the height of the bars on the left side will be very low. Here, the right side bar's height will be very low. This is called as right skewed. This is called as left skewed. Which side less number of values are there, that side is the skewed. Okay. So for example, let us take an example. This is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 60, 70, 80. This is 1 record. This is 2 records, 4 records, 5 records, 8 records, 12 records, 10 records, and this is 3 records. So here the records are increasing from the left side to the slowly, gradually increasing. One side it is increasing. Left side you are having very less number of records. In this case, right side you are having the less number of records. What is this height? What is this height means? The bar height, what is the bar height represents? Frequency only, right? Bar height represents the frequency only, right? Frequency means nothing but count only, right? I'm saying 0 to 10, only 1 value is there. From 10 to 20, 2 values are there. From 30 to 40, 4 values are there. So you are having on the left side less number of values, then it is called as left skewed. If you are having the right side less number of values, it is called as right skewed. Is that clear? Left skewed and right skewed. Now, so in the left skewed distribution, the mean will be less than the median. The mean is always in the center position. The mean will be always in the center. Where the median will be there? Where the maximum number of points are there in that particular bar, the median will be there. Sir, how, sir? Very simple. Very, very simple. This diagram is left skewed. Everyone accepts? Okay. Now, can I take here one number of 1? This is 2, height of 2. This is okay for you? If it is not okay, tell me. So I will take the data set, one example, and I will show you. Right? Now, this one is 3. This one is 4. This one is 5. This one is 6. And this one is 8. And this one is 7. Is that okay? Heights is okay. Every bar height is satisfying. Now, total number of data points, how many are there? 1, 2, 3, 7, 12, 18, 26, 33, 36. Total 36 data points are there. For 36 data points, which data point is the median value generally? For 36 data points, what would be the generally the median value? Which is 18, between 18 and 19. Where the 18th point will be there? Two first data point, 3 data points, 7 data points, 12. Where 18th data point will be there? 12 plus 18. Now 18 and 19, average of 18, 19 means that value will be here only, right? In this bar only that value is there. Where is your median? Mean is here, median is here. Now mean value is less than median. Is that okay? Satisfied? Take any data points of your choice. From 0 to 10, take 1 data point. From 10 to 20, take 2 data points. From 30 to 40, take 4 data points. Take anything of your choice between these data points, write in the notes. Any data points of your choice. 0 to 10, you have to type only one number. Any one number of 0 to 10. For 10 to 20, select any 2 numbers of your choice. Any 2 numbers. Whatever the number you want, you write in the notes. As per your choice. Write in the notes. From 20 to 30, select any 4 data points in the notes. 30 to 40, you take any with respect to 30 to 40, 5 data points. 40 to 50, 6 data points. 50 to 60, 8 data points. 60 to 70, 7 data points. 70 to 80, 3 data points. Write in the notes anything as per your choice. A data set you create now, which satisfies this diagram. Create a data set. Done. Created. Now for that created data set, you only calculate what is the median. You created one data set. For that data set, what is the median? You only calculate. And for that data set, what is the mean? You only calculate. Obviously, your mean will be less than the median. Is that clear, guys? Because the median value will be here. In this bar only the median will be there. In this bar, because from here to here, total 18 data points are there. Our median value is between 18 and 19, average of 18th data point and 19th data point, which is located in this bar. That data point is located in this bar. So means our median is here. My mean value is here because average of center value is 40. 0 to 80 divided by 2. What is center value? 40. 40 means this is the point. It is fixed point. Mean is not going to change anytime because that is center value. Median will change wherever the maximum height of the bar is there. In that position, the median will be there. Right? Now, so for left skewed distribution, the mean will be less than the median. And coming to the right skewed distribution, the median will be greater than the mean. Right? For normal distribution, mean is equal to median. The mean is equal to median. For left skewed, the mean is less than median. For right skewed, the mean is greater than the median. For right skewed data, the mean will be greater than median. Sir, we have to by heart, sir? It is compulsory we have to by heart like this. Don't by heart. Sir, without by hearting, then can you tell me a shortcut? Means in the certification, if they ask any question like this, can you explain with a shortcut? Okay, let me explain like this. Now for this data set, can anyone tell me whether it is a normal distribution or a skewed distribution? From 0 to 10, I have taken only one data point. From 10 to 20, I have selected 2 data points. From 20 to 30, I have selected 1 data point. Okay, I have written a small example. Now it is a normal distribution or a skewed distribution. It is a normal distribution, right? Now for this data set, can you calculate? This is a small example only, right? For this example, you can calculate the mean and median, if possible. Six, 8, 11, 11, 1, 51. 51 divided by 4. 51 divided by 4, right? Approximately is equal to 13. 12.75. 51 by 4 means 12.75. Average is 51 divided by 4. 51 divided by 4 only, which is equal to 12.75. Your median value is 13, which is almost close to each other. Now, let us take one more example from 0 to 10, 10 to 20, 20 to 30. This time you draw a height. 2 values from this, 3 values, 2 values, 1 value. It is a right skewed or left skewed? 0 to 10, 3 values, 8, 9, 7, 7, 8, 9. Can I take 7, 8, 9? 10 to 20, 11 and 12, 21, 20 to 30, 28. For these 6 data points, can you tell me what is the mean and median for this data set? What is the mean and median? $75 divided by 6, which is nothing but 12.5. Mean is 12.5. Median is 10. Average of 9 and 11, 9 and 11 is 10. Can you see the difference? Now, mean is less than median or median is greater than mean? Which one? So, this is median value and this is the mean value. So, median, or simply to say mean is less than the median. So, mean is greater than the median. Mean is greater than the median. In this case, mean is greater than the median. Mean value is 12.5, median is 10. Mean is greater than the median. The same thing. Can you see here? For right skewed distribution, the mean is greater than median. We no need to by heart. Take one small example. In the notes on the spot, you write one example for left skewed. Some values you create. If you take big values or more number of data points, calculation will take so much of time. If you take small data set, calculation will be simple. If anyone asks you to explain with a small, take an example, means don't take big numbers. If you select big numbers or more number of data points, calculation will take so much of time. Manual calculation will take so much of time. Right? So whenever some X person is asking, right skewed distribution means right skewed. Right skewed means this one is right skewed. Here 3, here 2, here 1. You select any 3 values from this range interval, from this interval, from this interval. Interval also your choice. If I select the interval 90 to 100, 100 to 110, 110 to 120, what happens? Big numbers means calculation will take so much of time. 0 to 10, 10 to 20, 20 to 30 means less time. For making the calculation simplified, I am taking the simple data set. So please don't by heart that median should be greater than mean, median should be greater than less than mean. Don't by heart that one. Just apply the logic. Okay. One more logic. This is one way. That is by taking some example is one way. Second way is by seeing the data set. In the data set, if you are having a normal distribution, for a data set, if you are having a normal distribution, this is a normal distribution where the mean will be there. This one fix, always center position. Whatever the value, it is 0 to 10, 10 to 20, 20 to 30 means 0 to 30 divided by 2, 15. 15 means here. This is the middle position. Mean will be in the center position. Mean will be in the center, automatically median also will be in the center position because the maximum bar is in the center. Now, mean will be here only. Mean is not going to change. 0 to 10, 10 to 20, 20 to 30 means 15 will be the center. 15 is not going to change. Whether the data set is like this or whether the data set is 0 to 10, 10 to 20, 20 to 30. Now, what is the mean here? Here also 15. In this case, 15. In this case, 15. In the three cases, the mean is fixed. Mean is not going to change. In this case, the mean is equal to 15. In this case, the mean is equal to 15. In this case, the mean is equal to 15. Mean is not going to change, which is in the center position only. Mean is not going to change. Median, wherever the large bar is there, that is the median value. Here, the large bar will be between 10 to 15. So, which is mean also in the 10 to 15 only. So, both are same. In this case, the median will be between 0 to 10. Take any number of your choice between 0 to 10, 9. Obviously, now median is less than the mean. Now, in this case, take any value between this, any value of your choice. Obviously, the median is, let us take between 22, 30, 21. 21. So, if you go with this one, or if you take the average of the largest bar, that is more better. Average of largest bar, that is 25. Average of largest bar, 5. Largest of average bar, 15. So in this case, mean is equal to median. In this case, mean is greater than median. In this case, mean is less than the median. Means for the left skew distribution, mean is less than median. In this case, the mean is greater than median. In this case, mean is equal to median. Easy to remember now? Is that clear? For left skew distribution and for right skew distribution. Why I'm saying this one like this? Because it is a mandatory question in the certification. Whether it is a NASCOM, whether it is a TCS, whether it is a Microsoft, whether it is anything. In statistics, they're asking any question, miss, this question is mandatory. This question is very compulsory. Whatever the certification it is, this question is compulsory. In the interview also, if one person is asking any statistics related question in descriptive asking, their question asking from the descriptive, miss, this question is compulsory. If they're not asking any descriptive statistics, miss, okay. If they ask, this question is compulsory. Right? Is that clear, guys? So no need to by heart particularly. Now, so left skewed distribution is also called as negative skewed. Left skewed distribution is also called as negative skewed. Right skewed distribution is also called as positive skewed. And normal distribution is also called as symmetrical distribution. Right? Symmetrical distribution. Left skewed distribution is called as negative skewed. Right skewed distribution is called as positive skewed. And symmetrical distribution is called as normal distribution. Clear, guys? Shape of the data is clear. Measures of shape means it is going to measure the skewness. Now, whatever the skewness is there, the skewness tells about the width. The skewness tells about the width, how the data was spread from here to here. Now, whereas one more shape is there, which is called as kurtosis. Kurtosis tells about the height, how much height of the data is there. That is kurtosis. The next one is called as kurtosis. Next one is called as kurtosis. Kurtosis tells about the height. If the data is from here to here, if the data is like this, then it is called as high and thin, then it is called as elliptokurtic. If the data is normal, left side and right side, the distribution of the data is same, then it is called as mesokurtic. Mesokurtic means normal distribution. If the data is flat, the height will be very less, the width will be very high. If the data is like this, width is high, with the height is less, then it is called as platykurtic. Okay, elliptokurtic, mesokurtic, and platykurtic. So, whereas skewness tells about the whether they are symmetrical or non-symmetrical, whereas kurtosis says about the how much height of the data is there. If the height is very high and with respect to the width is very low, means leptokurtic. Okay, and mesokurtic and platykurtic. Right? Is that clear, guys? That is with respect to kurtosis. Now, kurtosis and the skewness, these both tells about the measures of shape. These both of them tells us the measures of shape, how the data shape is there, right? The shape of the data. Now, sir, here you are showing some kind of curve. What is this curve, sir? Curve is nothing but, for example, you are having a data set like this. Okay, this is the data set. Now, if you attach all the data points in this way, and if you remove the bars, that is the curve. Curve is representation of the distribution only. The curve is nothing but representation of distribution, right? So, instead of representing a distribution in this way, we are going to represent the same distribution by using a curve. This curve and this distribution both are same. Is that clear? So, any data, any distribution, for example, I am taking a distribution like this. Okay, how this distribution will be represented? Just attach all the left side data points and attach all the right side data points. This is the distribution of the data. Right? The same bars, instead of bars, now the same data you can represent in the by using the curve. Okay, curve represents that from here to here the bar is this much. This is the bar size. That is the meaning of this curve. Okay, instead of representing the bars, we are representing just by using the curves. If the curve, whatever the curve is symmetrical, if the curve is symmetrical, means if you draw a line from the center, it is called as symmetrical distribution. If the curve is like this, what is this one? Left skewed. Left side slightly it is increasing now. So it is left skewed. Right skewed will be represented like this. So the right side tail will be long. That this is called as tail part. The tail, the right side you are having tail means right skewed. Left side you are having tail means left skewed. Left tail means left skewed. This is also called as left tail distribution. Sir, what is this, sir? These many names are asymmetrical distribution, non-symmetrical distribution, unsymmetrical distribution, skewed distribution, left distribution, negative distribution, left tail distribution. These many names they have created. Okay, left side tail is there, so left tail distribution. Right side tail is there, right tail distribution. Right tail distribution or right skewed distribution, both are same. Everything is same. And this is positive distribution, positive skew. This is called as negative skew. For this, only one and only name, called as normal distribution. No left tail, no right tail. Tails are not there because both sides are same now. So no left tail, no right tail. No left skewed, no right skewed. No negative, no positive. Both are same now. So only name is normal distribution or symmetrical distribution. Normal distribution or symmetrical distribution. And this curve, they have created the name for the curve called as bell curve. The shape of the curve will be bell shape. Okay, the shape will be similar kind of bell. So they have created the name called as bell curve distribution. One more name is called as bell curve distribution. The shape is bell curve, na? So bell curve distribution. What we can do in one textbook, one people are writing different way. One person will write, assume the data is bell shaped distribution. Bell shaped distribution means what is the meaning? It is a normal distribution according to him. One person will write normal distribution. One person will write symmetrical distribution. But concept is same. Everything finally what they want to say is left side and right side same number of values are there from the mean. That is the concept. Clear? Skewness and kurtosis done. So next concept is called as percentile. Most interesting topic, most confusing topic. Very good topic. Extraordinary topic. Important topic. What are the name you, right? Next heading is called as percentile. Now, what is meant by percentile? Percentage is different. Percentile is different. Don't get confused between the percentage versus percentile. Okay, percentage, percentile. For example, you have got out of 100, you got 78 marks. This is called as 78 percentage. This is called as 78 percentage. You have got the 78 percentage. What is meant by percentile means in your class, what is your position? This here, though you have got 78 out of 100 also, okay, what is your position? 78 might be first position, the 78 might be last position also. 78, okay. You got 78 marks, absolutely okay. Here 78 percentage, fixed. This is fixed. You whatever the marks you have got, this is percentage. This is fixed. Percentage says the position, not the value. Position. In your class, how many students are there? 50 students are there. In the 50 students, you got 78 marks out of 100. Na? What is your position? You are top, or you are the least, or you are in the middle. In which position you are there? That position tells the percentile. Percentage tells the position in the data. Position. It will focus on the position. This will not focus on the position. Irrespective of whatever the students are there. In your class, 100 students might be 10,000, might be 20,000, might be anything. 78 percentage is fixed. 78 out of 100 means 78 percentage. You got out of 50. Out of 50, you got 24 marks. What is your percentage? 48 percentage. This is fixed. Irrespective of in your class, whatever the students are there. But the same score here, 24 you got out of 50. Okay. In your class, what is your position? I want position in your class. Though you get, for example, I have kept an exam. Let us assume like this. I have kept an exam for 100 marks. Now, highest mark is 10. Highest mark is only 10. What is this percentage means? 10 percentage is the percentage. What is this percentile means? 100 percentile. It is a 100. He is the highest one. Na? Whatever the maximum value is there, the maximum value is called as 100 percentile value. I am comparing your value with the 100 percentile value, with the maximum value. I am comparing your value to the maximum value. That tells about the percentile. Percentile means position. What is meant by percentile means describes how much percentage of data values are below to you. If you say that I am 50 percentile, 50 percentile means 50% of the people are below to you. 50% of the people are above to you. If you say I am in the 90 percentile, what is meant by 90 percentile? Below to you, 90% of the people are there. In the CAT exam, we'll get percentile. 95 percentile, 96 percentile, 98 percentile. What is meant by percentiles means how much percentage of people are below to you. If you got 100 percentile, means 100% of the people are below to you only. Means every person are below to you. You are the first ranker. The first ranker is the 100 percentile ranker. Whatever the score he got, he is the first person. He is held as 100 percentile student. Not percentage student, 100 percentile student. Got the point? Example, let us take like this. So here, I will explain all these things. Let us take a small example. Total 15 students are there. This is the marks out of the 100. Sorry, now out of the 50. Score is out of 50. Now, if I make everything in the sequential order. Now, this person, this topper is there now. Topper has got how much marks? 43. He is the maximum marks. This is the maximum marks. 43 out of 50. What is the percentage? 86. 86. Are you going to calculate here? How many are there? Have you checked that one? Irrespective of this one. This side, one more student is there also. For you, 86 only. Here, one more student was there, 86 only. Here, for example, one person is 48 is there. Still, it is 86 only. One more percent of 48 marks is there also, 86 only. One more student of 50 marks also is there. One student has got 50 out of 50. Still, this percentage, what is the percentage of this student? Miss 86 only. It is not going to change. But coming to the percentile, he is a 100 percentile student. He is a 0 percentile student. Below to him, 0 students are there. Below to him, 100% of the students are there. Every student is below to him only. Okay, 50 percentile. This person below to him, 50% of the data is there. He is center. He is in the center position. Center position means median value. Median is called as 50 percentile. 50 percentile or median, both are same. Median means center position value. Position. I told you, right? Underline the word called as position. Do you remember that one? Position. Who is in the center position? Position is important here for me. In which position you are there? So center position means 50 percentile. This is called as 50 percentile. 50 percentile means 50% of the data is below to him. How many number of data points are below to him? That is the percentile. For example, let us take like this. I'm opening in front of you Kaggle. In the Kaggle, I'm signing. Right? This is my name. This is my account in the Kaggle. Right? This is my photo. And now here I have attempted one competition, one of the competition which is open. And here there is a leaderboard position. In this website, there is a leaderboard position. And if I open the leaderboard position, here we can see with respect to so total how many people has attempted this one? Just give me a minute. Total 15,852 are there. 15,852. Okay. Now, whatever the rank you are going to get. For example, I have got a rank of 100. Assume out of this 15,000, I have got a 100 rank. Now, this 100 rank is out of. If you don't mention out of, maybe 100 out of 100 means you are in the last position. Means out of 105 students, you have got 100 rank. Out of 110 student, you got 100 rank. Out of what? If you say that I have got 100 rank, means 100 rank out of. That is important. That out of is there, right? That out of tells about the percentile. For example, here if you observe, there is no, my name is not there. Okay, in the leaderboard portion, my name is not there. Right? Now, if you open let me submit my predictions. Earlier I have submitted. Let me 1 minute, just give me a minute. Here I'm downloading my whatever I have submitted earlier. Every 3 months once it will erase. Now in front of you, I'm submitting now. After 3 months, it will be erased automatically. Every 3 months once it will be erased. Now I'm submitting fresh. Okay, drag and drop. And I'm submitting. I don't know what would be my rank also. Just in front of you only I have submitted now. Okay. And I'm opening my leaderboard position. In the leaderboard position, once you submit, you can see your score, whatever the rank. My rank is 117. Right? You can see my name. Just now I have submitted 14 seconds back. Right? So my score is 117 out of 15,000, 117 out of 15,853. This is my rank, right? Example, that is dummy data set, and in the class we have worked earlier. We have not worked sincerely that one. If you do better miss, you get a better rank only. But for me, it is not important. For you guys, it is important because you are entering for the first time into data science field now. For you, this rank is important. For me, it is not important because already I'm having the experience. So they'll ask me what is my previous experience in my previous company, what I have done, and my projects, what is the projects I have done and what level of projects I have done. That is important for me. This Kaggle competition is not important for me. Certifications are not important. These are not important for me in this stage. What are the present stage I am having? But for you guys, this is one of the most important. Now here, if your rank is less than 158, means out of 15,853, 1% means 158. If your rank is less than 158, you are in the top 1 percentile. If your rank is less than 316, you are in the top 2 percentile. Based on your rank, whatever the rank you are having, your rank says this percentile. For example, in the resume, if I write that top 1 percentile, I'm going to write like this, top 1 percentile in Kaggle competition. I'll write in the resume like this. What is the meaning of this 1 percentile? Miss, out of how many have attended, within that I'm in the top 1. 1 percentile. I'm not saying my rank. I'm not saying about anything. Whatever the students has attempted, whatever the people has attempted, within that I'm in the top 1. Here it indicates the percentile, not the percentage. Got the point? So what is meant by percentile? Now coming to the percentile, for this data set, this is the called as 100 percentile, and this is called as 0 percentile. Whatever you are having in the center position, that is called as 50th percentile. This is called as 50th percentile. This is called as 25 percentile. This is 25 percentile, means 1/4 of the data is below to you. Median means 1/2, 50% of the data is below to you. This is called as 75. 75 means 75% of the data is below to you. That is the meaning. Sir, here total number of data points are 15, right? 15 data points are there. In 15 data points, 25% of the data, 25% of the data of 15 means what? 3.75. Now here for this only three data points, right? Including this one. Including this one. For example, you are having the data points. If the data points are even number of data points or odd number of data points, so that depends. If you are, this also will be included. The percentile means it includes with respect to your, so it describes the percentage of data values that fall at or at means on the same point or below to you, means including your point also will be included. In some data sets, your point also will be included. In some data sets, your point will not be included. Miss, what is that meaning? Miss, some data sets will have even number of data points. Some data sets will have odd number of data points. Got the point? Now, for example, I'm having even number of data points. That is 1, 2, 3, 4, 5, 6. In this case, what is the median? 3.5. Here is the median. This value, whether it is included in the data set? No. But if you go with the same odd number of data points, this value is included in the data set. Whether the median will be included in the data set or not, miss, what is the answer for that? It depends on the data points. If it is odd number of data points, median will be included in the data set. If it is even number of data points, median will not be included in the data set. Sir, for example, this data set is having 3, 3. Now automatically average of 3 and 3 also 3 only, right? Now included or not included? What you are going to say then? Can you say like this? Whether the median will be included or not, miss? For some data points, it will be included. For some data points, it will not be included. There is no fixed rule for that. Every time the median should be in the data set only. There is no rule like that. At the same time, there is no rule that the median will not be in the data set. It depends on the data points. Example I have shown you, right? 3 examples for 1, 2, 3, 4, 5. This is the data set. 1, 2, 3, 4, 5, 6. This is the data set. 1, 2, 3, 3, 4, 5. This is one more data set. For 3 different data sets, you are having a different way. Here, value is directly selected. Here you have taken the average. Here you have taken the average, but unexpectedly that average is this average, this value only. What we can do? Every time the average will be the same value. No. That is completely dependent on the data points. Is it clear now? Similarly, percentile also same. Right? Percentile also same. Percentile also with respect to same, where we are having with respect to the number of data points. What are the number of data points we are having? This is called as 100 percentile. 100 percentile means 100% of the data, including him. Including him, everything is 100% of the data is below to him. Including this, 75% of the data is below to him. 50% of the data is below to this. 25% of the data is below to this. Why you are selecting 25 percentile only, sir? 26 or 27, you can select anything, right? Why you are selecting only 25? 25 is called as quartile. 25 percentile is called as quartile. 25 percentile is called as quartile 1, which is also represented by Q1. 50 percentile. 50 percentile is called as quartile 2. Quartile 2 means 2 quarters are completed. 2 means not that quarter. Okay. This one only. 25 percentiles. 225 percentiles combination is called as 50 percentile, which is Q2. 75 percentile, which is quartile 3. Quartile 3. Quartile 3, which is Q3. Each of them is called as quarter. And 100 percentile. 100 percentile is called as maximum value. 0 percentile is called as minimum value. 0 percentile is called as minimum, 25 percentile as Q1, 50 percentile Q2, 75 percentile Q3, and 100 percentile as maximum for a given data set. Okay. Okay, sir. We have percentile. Okay. Now, what is the use of this one? That is most important. Percentile we have understand. Now, what is the use? Why we have to calculate the percentiles and what is the use of percentiles and quartiles? That will continue in the tomorrow's class. Right? Is that clear? So just revise whatever we have discussed till now, and tomorrow we'll end the complete descriptive statistics part. And once the descriptive statistics is completed, the theoretical part